Okay, audiophiles, here's something else for you to worry about. Now, I didn't dream this up all by myself. A commenter specifically asked for my recommendations on how to cool an integrated amp. So what did I recommend? I didn't, because I'm not an expert and I'd only be guessing. But it did make me want to investigate further. Should audiophiles and hi-fi enthusiasts be worrying about cooling their gear? Should I? Will audiophile-grade cooling improve the equipment's sound? Will it help it last longer? What other benefits might cooling give us? Might there be any problems, any rabbit holes? I think I should start with the need for cooling. Is there a need? Well, yes. To put it simply, your equipment will fail if it gets too hot. If it doesn't fail, it will degrade, and you won't get the performance you expect. So, any competent manufacturer will design thermal control into their equipment. The simplest method is drill holes in the case to let the heat escape. Not much brain power necessary for that. But where should the holes be? Should the gubbins inside be designed to direct heat through the holes? Competent design will see to that. The second simplest method probably is to bolt a heat sink to the case. If you've ever looked at anything that generates heat and you've seen vertical metal fins, you've seen a heat sink. The fins get hot, they conduct the heat to the surrounding air. The fins have a large area of contact with the air. They're vertical because, hey, heat rises. You may have noticed I used the phrase thermal control. That's to make it sound posh. Holes and heat sinks are a start, but certainly not the end. Add a fan to actively blow the air out of the enclosure, or maybe over the heatsink. And then we can get really posh and have internal temperature sensors that can tell when things are getting too hot and throttle things down. Your computer does this. That's why the longer you work at your computer, the slower it gets. There should be a name for this, similar to Murphy's Law or Sod's Law or something. Commenters, please suggest. Now, this is where things get audiophile and maybe something to worry about. Suppose your Class A amplifier is getting too hot. Class A amplifiers run at high currents all the time, so they do create a lot of heat. But what happens if they get too hot? Thermal cutoff is one solution. Just coming to the climax of Mahler's Symphony of 1000, enjoying it. Oh, the amp thinks it's getting too hot and cuts out. Symphony of 0. But it doesn't have to be this way. What if when the amp is approaching getting too hot, a clever little circuit switches on a fan? Oh dear, but I'll come back to fans later. What if there's a rather more clever circuit that reduces the amp's performance like a computer would? Oh dear, again. You've paid megabucks, mega quids for your Class A amp, and now you're getting reduced performance. I spent some time on Google and I couldn't get to the bottom of this. I think perhaps because amp manufacturers don't want to talk about it. But I could speculate how such a system could work. So, your Class A amp is running hot. Class AB amps don't run so hot because they run a much smaller standing current. What if your Class A amp could dip into Class AB for a while? I am just speculating. If this were possible, then fine, the amp would cool down. But you paid for a Class A amp and you're hearing Class AB. And is there an indicator light to tell you this? I very much doubt it. What grade of audiophile are you? Could you tell? OK, that's speculation, and I'm sure commenters will have comments to make, and maybe suggestions. It's all part of the fun. For even more fun, you might consider that when a Class AB amp heats up, the output transistors pass more current. Therefore, the bias needs to be automatically adjusted to compensate for this. So, as the music gets louder and quieter, the bias is going up and down like a bride's nightie. I didn't make this up. It's something that internet audio enthusiasts fret about and wonder whether they can hear it. I merely comment, don't shoot the messenger. Now, I'm going to come back to fans, amps with fans. Come on, that's just a great big no. Professionally, of course, power amps can and do have fans. But no one goes to Glastonbury and complains about the fan noise, cooling fan noise. But in your super silent, acoustically treated listening room, do you want the sound of your megabuck system compromised by fan noise, even at a low level? OK, modern fan design can be quite quiet, but silent. And really, is it right? Is it audiophile? And so, we turn to alternative cooling methods. I've mentioned ventilation and heat sinks, and for completeness I should also mention airflow around the equipment. I know it's obvious, but sometimes the obvious needs to be stated. If air isn't free to flow around your amplifier, then it won't be cooled efficiently. Just do it. But we can take a tip from our computer enthusiast friends who build their own systems. Of course, they want their processor to run as fast as possible, beyond what the manufacturer states is permissible. This creates a lot of heat. And of course, the first solution is heatsink plus fan, directly on the processor. And of course, fans and vents in the case. But the next level solution is, and you have to believe this, water cooling. Like your car. Water jacket, pipes, pump, radiator. Cool, man, cool. I don't believe that such computer enthusiasts are bothered about a bit of noise from pumps and fans. But the principle is good. For audiophile-grade water cooling for your amplifier, the pump and radiator could be in another room, or outside even. You know where I'm going. Air conditioning, a split system. The evaporator, like the indoor unit, cools the amp. Pipes take the coolant to the condenser, which is outdoors. Is there any reason not to do something similar to cool your amp? I see nothing in principle. Can we go further? Or have we gone far enough yet? Solid state refrigeration. No coolant, no pump, no fan. No liquids, gases, or moving parts at all. This was once thought to be impossible, but now we have the Peltier effect, the magnetocalorific effect, the electrocaloric effect. I told you I had to Google, just trying to read it correctly. OK, I think I've gone far enough with this for now. If there are questions to be raised, they would probably be these. Passive cooling is good, but is it always as effective as it needs to be? Fans may be necessary in some equipment, but do they compromise the audiophile experience? Thermal management is necessary in power amps, but may some methods be audible, or at least something for audiophiles to worry about? There are more advanced methods of cooling. If they were made available to hi-fi enthusiasts and audiophiles, would this be a good thing? I look forward to your comments. See you soon.
Hi, I'm Phil, Audiophile. For casual listening, I chill my equipment with precisely calibrated ice packs made from pure glacier water to render crystal clear sound. For more intense musical genres, I opt for dry ice, which sublimes gracefully into the air as the music plays. On very special occasions when I play Miles or Bill Evans, liquid nitrogen is my go-to and helps me achieve the ultimate in cool.